Okay, I hope you are here. Again, it is not operating with the, I don't know what happened. Change the system and it. We'll see what we can do. Successfully open dynamic library thing. Something happened. Okay. So what happened? Just a minute. We use only Keras. This is a problem. I don't know what's the problem over here with the libraries and all. Just now this library worked, okay, but now it is not working. Okay, now go Keras. That's why I don't prefer this thing, only because this is having a easy data source. That's why I am using this Kaggle, but with the Kaggle, there are a lot many problems are there. Some I don't know like when the code will stops executing. Just now things were executing, right? But now again it stops. Now it started executing. Now it executed. So when God knows whenever it may stops anytime, things will again we have to re-execute. Without any now again this is not executing. Now it started execution. The only change is over here that I'm using Atom, but with Atom it should work. It is not like that with Atom it should not work. And this image data generator is fine, nothing to worry about it. That is image augmentation. So let me give you a quick review. So recap. So it's like first of all, we created a model using this process. Okay, so we're using this process. Only changes that it is having is I am using over here one hidden layer. Okay, so in the next model, I'm not using the hidden layer. That is the one thing that I'm doing over here. Okay, rest all things are very simple. Okay, just a minute. Okay, rest things are very simple. The way I had to use the next model. So this model I'm not deleting from here. It will remain over here. Okay, so that we can compare later on that what are the why it is not working exactly, right? Because the next model is working properly, but this model is not working. So what's the we can compare and can do the changes, right? Rest the next model is working properly. We are getting a good accuracy as well, but this model is not working. So that's why I'm not removing it because so that we can compare later on as well. Okay, so let it be finished. Okay, and then till the time it is getting finished up. Okay, let me add the dropouts because it is showing a. So it is what first convolutional layer, activation function, then batch normalization. Then again activation function and batch normalization. Okay, then dropouts. Okay, then again over here one more dropout. Then over here one more dropout. 40% dropouts we are doing because it's a overfit model. Then 50% of dropout. Okay, and then right. So now it is done, right. So this particular model is known as what VGG16 architecture. Okay, so let me show you the VGG16 architecture actually. 16. So it is what if I will show you. Okay, so you can see it is known as your VG16 architecture. By default, we are having what some image set of size 224 plus 224 plus 3. Okay, then there are 64. There are two. You can say there are two times. This is the very successful and very powerful CNN architecture actually. There are two times you can see 64, 64. There are two times 64, 64 kernels are used. Then there is your max pooling. Okay, and after max pooling, three times we are using 128, 128 kernel. Then again max pooling, and then again we are using what? Three times 256, 256, 256 kernel like this, right? And then again max pooling, and then again we are doing it for the three times. Correct. Again then we are doing it for the three times. Okay, and again max pooling, and then again. So that's how first for the first two stage we are doing it So we are using only 2 that means 2 times we are using what, kernel. Okay, we are just doubling the kernels, okay, and increasing the, we are just keep doubling the kernel and then keep using the max pooling, right? So it is known as what, it is known as your Vg16 architecture, which is very successful. Okay, right now also it is working very nice in our case. There is architecture that we created. Okay, so these things are not going that well. I had made the changes, but still it is not performing well. So I'll just compare it later on what the changes, why it is not working so good. Okay, but ultimately at the end we are having a VG16 architecture which is working very well. Okay, so in this architecture you can use multiple. Okay, it's our reference from previous model, and this is what VGG16 VGG16 architecture of CNN. Right. So this one is working a little nicer. Okay, I'm using dropouts as well, so I can expect a more accuracy. Now accuracy is already good. I can expect a little bit less overfitting, right? Okay. So we are having what at the end. Okay, so even it is not getting overfitted, it is around 72% accurate model. And like earlier we were getting around 60% of accuracy just because of batch normalization and regularizations. Okay, my accuracy improved a lot, and because of all those parameters, the overfitting is also avoided. Okay, now we'll try to, once it is done, then we'll look for the predictions part, as well as we'll just use some image from the Google. I'll just download the image of cats and dogs from the Google and try to make the predictions, right? Done. Okay, then evaluate it. So it goes up to 78% accurate, and then it is also around 73. That's fine. We can use more number of epochs for a more accuracy. Now let's take some data from X test. Okay, X test. Suppose I am taking a data 678. Okay, there is information 678. Okay, so first of all, take it from the normalized form. Okay, X test C. Okay, then do what? Then just plot it. Okay, so for plotting, we'll do what? Import matplotlib dot pyplot as plt. Okay, and then plt.imso plt.so. So it is looking like a dog. So let's see what's the label is over here. If I check for the label, I am having a label of y test 678. So label may be 0, okay, because 0 is representing the dog, right? Now, what I'll do, I'll just make the predictions. For making the prediction, we'll do what? K model dot predict, okay, x tail 678, right? Not working because of shape problem. So just check out the shape of the data which is used for the training, xtrain dot shape. So if I check for the xtrain k, what is saying that it is not there? Okay, train, right? Okay, so first thing is representing the sample size, right? Second thing is representing other things. So dot reshape, okay, 1 cross 80 cross 80 cross 3, right? So it is getting predicted over some value. Now, which one is what is it exactly predicting? We can use what? Import numpy as np dot arg max, sorry, np dot arg max. Paste it over here. It is one, right? That means over here, at least the predictions are not well over here. It is not correct. So let me try with some more samples, some different samples, right? 67. For 67, what are we getting? We are getting, sorry, 67. 0, we're getting 0, and 67 is what? Let me check once. So many cases we'll get the correct predictions. There can be some cases we can increase the number of training and all those things, right? 67, right? Now I have to check for which it is accurate for which model, for which kind of thing. So we are having what we'll predict for all the data. Okay, let me try with some one more data as well. Okay, 855. Okay, why do you one always 983? Oh my God, 1000. Oh, no, it is one. It's fine. So it is one. So 1000 for 1001. What is it? Must be cat, right? It is predicting one as well. And what's the image? So it is a cat, right? So it is identifying correctly, right? Now I have to check the confusion matrix. So for the confusion matrix, let's make the prediction for all the data. So k model dot predict uh, x test. Okay. And k model dot predict x test C I should use the normalized form for a better output, right? Then we can do what we can do for spreads in for all the predictions, right? np dot arg max spreads. So it is like 0 or 1, whatever it is there, right? So this predicted value y test spread is equal to null. Okay. Then y test spread dot append. We can append it, right? And then after you can check for the confusion matrix. For the confusion matrix from sklearn dot matrix import confusion. Let's say import confusion matrix. Okay. Then confusion matrix y test comma y test P. Few confuse. So it is more accurate. It is almost okay. It is more accurate for category one, I guess. That is for the cats. Okay, for the dogs, there are so many errors are still there. We can expect a little bit more accurate model if we increase the number of epochs. For example, let me execute it for 20 more times because it is not getting at least overfitted. So I can execute it for more times. Okay, like it is already executed for 30 times, right? So if I'll execute it for 20 more times and we can increase the number of hidden layers and other factors as well. So what will happen? This is the last training that we are providing. So with the hope that it will perform more better. It is performing better on the training set, but for the testing set, things are not going well for it. Means it is going well as compared to earlier, but not that well. We can expect more accuracy, right? We are using regularizers, we are using a dropout. Okay, more dropout can be used. So we can expect less overfit model. Okay, till then, let's download some image from the Google as well so that we can use them. Cats and dogs images. Okay, so let's. Okay, so these are the cats images, right? So let me download it from here and then let's try to use it for the prediction. If it can, if it is trained, then it can may predict a better download edge. Cats, okay, on the desktop. Okay, and the second one for the dogs. Which one I should use? Should I use this one? Okay. Now let's upload these images. So how to upload? We have to add a data, load, file. So these two things. Just a minute. Let me rename this thing. What is rename? Cat image. I guess because of cats. This. So, not accessing this. I guess this is already there. So I have to use some other image. Okay, so this is the test image that I have uploaded right now. Let's use it. So at the end, my accuracy come out to for training around 92%. For testing, this is 97%. That's fine. Getting predicted as whatever it is. So confusion matrix now a little bit improved. Okay, it is now improved a bit, right? As compared to before. Okay, it improved for the test data as well. Right, point test. Okay, let me use some data set over here like 5670. And what is the prediction for 567? Is actually a I don't know what is it. It's for zero. It must be dog, right? Sorry, cat. Right, it's a dog. For zero, it's dog. For one, it is cat. That's fine. Okay. Now let's take the image from here. Test image one. Test underscore image underscore one will be equals to this thing. Okay. And test image two, that will be equal to this thing, right? Okay. Now what we'll do, I'll just import CV2 is already there, but still let me do it everything from scratch. So import CV2 IM1 equals to CV2 dot IM read. So here the image need not to be converted into a grayscale image. You can use it as it is. Okay. Test image one, right? Okay. And thereafter I can IM1 is equal to CV2 dot resize. Only resizing is required because IM1 because data is using 80 cross 80. Okay. And thereafter IM1 is equal to IM1 divided by IM1 dot maximum, right? The same as for the IM2. Singular IM2, IM2, IM2. Singular IM read, this is your test image 2. This is your IM2. Here also I have to change it to IM2. And here also I have to change it to IM2. Two images are there. Then I have to make the predictions. Making out the predictions, we will do what? Simple model dot predict IM1. Okay, so there may be some shape error and all. Model is not defined. Okay, it's a K model. Sorry. So something I'm getting. Let's see. What's the error? Input zero. Okay, it may be shape error found as. Okay, fine. Okay, got it. So I have to do it. I have to reshape it. Dot reshape 1 cross 80 cross 80 cross 3. Okay. Now we can plot it. Okay, that means we can get the NP dot ARG max. Okay, and then I can print this guy. Okay, and then PLT dot IM so IM1 and then PLT dot so. So if the same data you will use for simple ANN, you may get a very bad model. Okay. Here, just try using the simple ANN. Here, we are at least getting accuracy close to 80%. With simple ANN, you may not get that much good accuracy. Okay, so it is what IM2. IM2. It is 0. 0 stands for what dog and 1 stands for what cat, right? As per the labeling that we had given. Okay, if you see over here the labels, okay, in the labels, the location, okay, training set. First of all, we are accessing dogs. Okay, and then we are accessing what? Accessing the cats, right? So that's how label is given. First of all, it is accessing dogs, then it is accessing cats, right? So we can do what? We can define a label over here. Okay, labels. Okay, image label is equal to, first it is dog, and second one it is cat, correct? So that I can directly use image underscore label. So it is identified as cat, and then so from the random data, just a minute. Right? So now it is done, right? So you can try with the CNN, with the normal ANN, you will not get the good accuracy, only CNN can solve it because every image is having a different orientations. Okay, it is not like a single orientation we are having. The shape is playing a very important role in this model, in this for this data, because the shape of ear, shape of other things of the image is playing a role, which will be the thing. So which will be used to identify the identify the image. So while you are using it, we need to use a model that can preserve, that can keep using the shapes. Okay, the information about shape should not be used. The pattern within the image, the pattern within the image should be there. That means should be stored, and that only CNN can do. So let me save this file again so that you can access it. And I have saved this thing with you. You can access it and go through it. And I can wait for next 5 minutes. And thereafter, if you are having anything to ask, please let me know. Thereafter, we will work with some higher cascade thing and all. Once it is done, please let me know. We'll go for the next. Please just execute everything on your own end, okay, so that you can see like what I'm saying. Like, please execute everything once at your end. It will hardly takes 10 minutes, right? So that you can come to know, okay, which is executing, which one is not executing, because it's not just the concept that will help. It's just a kind of experience and patience that is also required. So just let me know if anything which is not working at your end and it is working on my end, so that we can discuss that and we can solve that, right? Are the things working? Have you tried? Please tell me. Shall we continue? Okay, that's better. Is it working? Have you checked? So now let's see next what we will do. Next program, just give me 1 minute, please. That we will do. We'll execute on the system. That means I'll not use this Kaggle, I'll not use Collab. Okay, so let me try with for face detection. I'll use what I just try to use this thing. The offline coding. Okay, so for the offline coding, I'll start working. Like I have already installed the thing. Like what is this Jupyter and all my system. So let's start Jupyter. Right, not like this. Okay. Page environment estimate slash What happened? Okay. So it's a Jupyter notebook that is running on the offline system. That means it is not using any cloud service. And now it will use my own system resources. Fair enough. So to start coding over it, I have to do what? I have to start at new and then Python 3. So I'll get what? I'll get a environment where I can code. Okay. Now we have to work with what the face detection thing. So for the face detection, we require what we require some of the like. I'll also let you know how can I create your own data for the face detection and all. So before telling you how to create your own data for the face detection, let me tell you how can we use the pre-trained model. Okay. So one of the pre-trained model is this thing. I'll show you. Uh, Hair cascade, okay, that people are using and it is a little bit successful as well. Okay. I have shared this thing over the GitHub. I'll share the link with you. Let me access first. Okay, hair cascade. So this hair cascade is what? It is a file that is containing a different trained model for identifying or detecting or recognizing different uh, facial things like eye, frontal face, smile face, and non-smiling face like that, right? So out of this thing, this frontal face.xml can be used by us. Okay, frontal face. This frontal face default is also there. Okay, hair cascade frontal face default.xml. It is a very nice algorithm. Okay, so you can click over it. So when you click it, it will open up. I'll share the link with you. Then you can click over this raw button, okay, and then right click and then save page as. Okay, so it will be saved somewhere in your system. So let's see, I am selecting this thing called desktop. Okay, on the desktop, I'm saving it. Right. So this file will do a lot of jobs. So I saved it on the desktop. Right. I'll give this link to you. You can also access this. It is open source. Okay, you can download it. It's a pre-trained model that are uses for the face detections, right? Okay. Now you can use online, offline. You can use Collab as well. If you're using Collab, then you have to upload it. But since uh, I will also use webcam later at the later stage, that's why I'm not using Collab because through Collab webcam I can't access. Okay. So now import CV2. Okay. Let me check what is there in my system or not. So it is there, that's better. Then I have to define two things. First, image path. Okay, image path is what wherever the image is present. So it is present at desktop, right? So, okay, there is no image over here. It's a hair cascade file. So let me copy this thing. Properties. Okay, it's a cast path. Give me 1 minute. And then I need an image path as well, right? So for the image path, actually, what I did over here, just a minute. This is the okay. Just wait a minute. I'll take a image. Where is image? Okay. Let's suppose I'm taking this. This is having faces, right? So just save image as faces. Okay, I saved it, right? And then I'll access it over here. Like this. Still getting again for just a minute, just give it a minute. Okay, so image path is done. Now what we can do? So image is defined, hair cascade file is defined. Then I have to read the image, right? So for reading the image, what you do? cv2 dot read or I am read. Okay, what image path? So it will recognize. Okay, so image detected. I can store this thing into image, right? Then we have to create a hair cascade. So for creating a hair cascade, there is a way of using it, right? It's a pre-trained model, so there is a way. So what the way? Create a hair cascade. So it would be face. Just give me 1 minute. Just 1 minute. Okay. Face is equal to cv2 dot cascade classifier. Cascade classifier cas path. Right. Now to detect the face, I have to define an object called my faces that will be equal to. This is a cascade that is defined. So just copy this face. Sorry, face dot detect multi-scale. Okay. Face dot detect multi-scale. That means a multi-scale, right? That's fine. Then I can do what? I can pass the image over here. Image. Okay. It will detect the thing. Thereafter, I have to define minimum size. That means what you can say that what if I define our minimum size equal to 25 cross 25. So in that case, if a face is covering less than this much area, okay, then that face will not be recognized. Okay, minimum it will be up to 25 cross 25. Correct. Thereafter, scale factor. Scale factor. Okay. The scale factor is equal to what? 1.1. So what is this scale factor? Let me tell you. If you are having an image, for example, over here, like suppose I'll plot the image. Just a minute, let me get the image over here and show you. cv2 dot im show image cv2 dot weight key 0 cv2 dot destroy all windows. Okay. So wait key is doing it. Whenever I execute it, there'll be a window opened up. Okay, if there is no error. Okay, but it is error, so I have to just give it like this. Okay. So there will be a window opened up showing the image, right? Whatever the image that is present, this will be there. Okay. It is showing some image, right? Now with this image, what happened? Whenever I click over wait key 0 means what, it will wait for me to be wait for me when I am pressing any key. Whenever I place any key on my keyboard, it will destroy all the windows, right? That is what it is doing, right? So let me do one thing. Let me decrease the size of the image because it is by default very large. So the detection face detection may not be easier. So cvt dot resize image, comma, like 500 cross 500 something. If I give, uh, we can use what? It's a width should not be decreased more. Okay, so let me use width as 700. That's fine. Okay. So now when this particular image we are putting where we are putting into the detect multi-scale. So detect multi-scale will take this whole set of image. Thereafter, it will do what? It will just a minute. It will do what over here? Yeah. That means we are going to. It will just take one. That means complete whole set of image. Can't be defined like this. Just a minute. That means it will take whole set of image like this, first of all. Okay, wait a minute. Let me put it over here. Oh, God. Okay, it's fine. So you are having a whole set of image like this. Okay. Thereafter, I have defined scale factor 1.1. That means with a scale factor of 1.1, it will it will consider a smaller portion of it to verify the feature. That means it's like kind of slicing the image with a scale factor 1.1. It will go smaller, smaller, and smaller. Okay, with a continuously with a scale factor of 1.1, it will just go more smaller, right? More smaller from all side. Okay, from all side, it will take a scale factor of 1.1, one by one, right? From all the side, it will take the scale factor from all the side to take the scale factor of what? 1.1 with a distance of 1.1, right? And consider and keep going. That means it's like cropping the image. Okay, so image will be cropped with a scale factor of 1.1. Okay, and then you have to define over here how many image you want to compare at a single time. That is called minimum neighbors, right? So minimum neighbors is equal to 5. So at a single time, it will pick up 5 different images. Okay, 5 different smaller by slice. That means it will slice down, or it will just what that is, crop down 5 parts of the image. Okay, that means crop and create 5 different images, a smaller size, and compare the face, like where the face is present or not. So it will go up to the as small whenever the face detected, and thereafter at last flags is equal to cv2 dot cascade scale image. Okay, minimum neighbors is showing error. So NEI, okay, minimum NEIGHBURs. NEIGH. It's capital N, I guess. Right. And then after, if I call my faces, okay, so what I'll get? My face, sorry. So I'm getting 1, 2, 3, or 5 values. Okay. 5 values, I can get 5 rows. So 5 rows means what? From this image, actually it is detecting 5 faces. How many faces are there? Actually 5 faces are there, right? So what it is detecting exactly? The very first thing, it is detecting the X coordinate and Y coordinate. This is representing the first 2 factors you can see over here. This is representing X and Y coordinate. X and Y coordinate of each face. That means over here. Okay. It can be like this. Okay. It can be like this. From where it is there. Right. Okay, and thereafter these two things are representing width and height. Width and height, right? It is what? Width and height, right? So if you uh, add width into the value x, you will get this thing. If you add height into the value y, you will get this thing, and then this thing will be connected together to to define the area in which face is present, right? X plus y plus x plus w, y plus h, and we can draw the rectangle, right? So let's do it. Okay, uh, fine. So just see, if I want to draw any kind of shape on the image, what I can do? I can do it like this. CV2 dot, okay, CV2 dot rectangle. Rectangle, right? Rectangle what? I have to give the name of image where I want to draw the rectangle. Second, I have to give the x and y location, that can be like suppose 50 cross 50. Okay, then I have to give x plus w, that means x plus weight, so 50 plus 50 or 50 plus 100. Okay, comma 50 plus 100, that means I am drawing a square. Okay, and then the color of rectangle, if I want to make it red color, so 0 comma 0 comma 255, it is BGR, right? And thereafter I can give the width of the rectangle too. Okay, so if I execute, you can see there is a rectangle drawn in red color, right? So that means it is what? Okay, so that is a rectangle already there. Now if I will comment it, then also you can see the rectangle, it is drawn over there. This line of code is commented, still it is there, right? So what I'll do, I'll again access the image. Now it is removed. Okay, so I'll use the same process for drawing the rectangle around the face, right? So for x, y, w and h, x, y, width and height in my face, right? CV2 dot rectangle, I'll just copy and paste from here so that you can see like, okay, I'm using the same thing. Control C. Okay, image. Okay, it will be what? X, it will be what? Y, it will be what? W, it will be what? X plus W. Okay, and this is what? Y plus H. That's it, right? So as I execute, it will draw the rectangle. Okay, and thereafter, what we can do, we can call this thing that we did earlier, paste it over here, right? Okay, and then here I can do what? Like number of images, like faces found, faces found. Okay, and then how many faces found? So plus str length of what? Length of my face. So my face is having a length 5, so 5 faces. So if I execute, you can see at the top it is rightly written faces found, and these are the 5 faces that it is detecting, right? So if you keep changing the image, whatever the faces are there, it can be used to identify. That's how your hair cascade works. But hair cascade is having so many other things. Okay, it is not. It can detect the smile. It can detect so many other factors, right? So you can try using those things. Okay, I'll give you the link from here. You can get all different hair cascade files. Okay. There are so many files are there. Okay, so you can just download this thing, any one of them. Okay, and based upon your own requirement, like glasses, it can detect the glasses. It can detect many other things, right? So glasses on the face and all. So you can just use it for the purpose. So let me save this file. Face detection, right? It is already there. Just detect. Okay, I'll download it and I'll share with you. Download as IPYNB. I have downloaded it. You can access it into your system or you can upload it onto the Colab as well. If you want to upload it in the Colab, you can upload this thing into the Colab as well. Okay, I'm just uploading it into the WeTransfer. Just give me 1 minute, okay? So I have uploaded it. I'll copy the link and share it with you. I'll tell. The last argument is represent. Yeah, absolutely. Okay. The last argument is representing what? It's a width of the rectangle. Okay, with whatever shape you are drawing, the shape is having what? The width of that particular shape. This OpenCV play a very important role in the computer vision. Okay, if you have to work with a live image, live video, okay, you need to be good in OpenCV. That is computer vision part. No worries, some more examples I'll give you. This is the first example. This was very simple. Okay. So just go through it once. I have shared the file with you. Right. Just access the file and download it. That file will only open in some of the ID. Either it's a Jupyter ID if your system is having, or it can be a collab. Okay, you have to upload over collab for accessing it. Just access it and let me know if you're having any doubts. I can get to 5 minutes and then the next part.
मैं तो वही करूंगा ब्रो। मैं समझ गया क्रिएटिव अपने बस की है नहीं, क्योंकि भाई टाइम जाना चाहिए। पता चला पैसा लगा दिए जैसा ही।
Okay, I hope things are working well. I just go to call and okay. So next what it requires okay. Next, what we can do, we can just see like if it is for the like for object detection, we need to know like how can access the webcam and all. Okay, like it is for the stable image, right? And if we have to work for the video, is it working? Please just try once because later on things will later on if we will work on and if anything will not work, so it will be difficult for me also to help out, right? So that's why I'm saying like you can give a little time. I'm just giving you the code. You can just give a little time to figure out. Next, it's like video like just detection, video capture, and face detection. Okay, first of all, let me tell you how to capture the video, right? So for capturing the video, what we can do, it's like import again, same thing, import CV2 again, and then IM is equal to CV2 dot video capture 0. Okay. Then state comma frame. Now what is this video capture 0? Video capture 0 is actually where we can, if you're giving 0, it will access the webcam. But if we are having some video in your system, that also can be given over here. So let's see how it can be given. Sorry, I thought like I'm sharing my screen and then I stopped sharing it. And it was I was speaking continuously. Anyway, so you can see over here what changes I made over here. The thing that I made, it's like I thought like I'm sharing my screen. I don't know when I stopped when the screen said stopped. Okay, so this is doing what? This was actually finding the faces and all. So let me remove this part and explain this thing quickly. Okay, so it is doing what? It is just identifying the face if it is there, right? So I had given what? I had just given over here one more line of code. It is doing what? If the length of my face means what? Length of this thing. Okay, obviously, whenever face will be found, it will have a multiple entity. Okay, so if it is more than 0, okay, that means if face will be detected, it will have what? It will have coordinates of face. So if that means if the entity is more than 0 on the CV2, okay, or sorry, on the image itself, okay, there will be a text written. The text is what? Face found, right? If the face found, right, when this is more than this one, okay, else face not found. It is the location of face, sorry, location of text where the text you have to write. This is a font of text. This is what? This is kind of a way, the width, or you can say the, what is it? The size of text, okay, it can decrease or increase as per your requirement. This is color of text, this is width, and this is the style, right? So if I execute it, if face found, it is showing face found, right? If I will say, if I'll execute by closing the cam, it will say no face found, correct? So it depends, right? So same line of code I had written where I had written in the while loop. Okay, so in the while loop again, I am doing what? First of all, in the while loop, which you learn for the infinite times, in the while loop, first of all, what is done? CV2.video capture 0. That will identify the, it will just get the webcam access. Okay, and from the webcam, whatever it is getting accessed, we are reading it in the while loop. That means it will access the webcam for infinite number of times until unless it will be interrupted. Okay, and whatever image that is captured, whatever frame that is captured, from that frame we are trying to detect the face. If the length of face is more than 0, then it will say what? Face found. Okay, if it is not more than 0, it will say no face found. Okay, and whatever the coordinates that are figured out, around that coordinates rectangle will be drawn, right? And then when we press the button Q, it will be queued. Okay, so let's see. Okay, so it is saying face found, and if I close the webcam, no face found, right? And now again it is saying what? Face found, right? So that's how your hair cascade works, right? Okay, now he had texted me something over here. Okay, so fine, let me share this file with you once. Okay, so that you can go through it. Okay, and then let me know that if you're having any doubt, because this project can help you in doing the project which can identify the mask on the face or something like that, right? So share it. Download as. Okay, whatever that is downloaded earlier, first of all, let me delete that one. Shall I share IPYNB file or the Python file? If you want Python file, you can just let me know. I'll share the Python file as well. What happened? I'm sharing this file with you. Please access it, execute it, and let me know if you're having any doubts. Please go through it and let me know if you're having anything to ask from here to discuss. No, I'm not speaking anything. I just you want to ask something? Actually, there is no audio distortion. I will not speaking anything. I had shared the file with you so that you can go through the things and let me know if you have any doubts. Right? Is the hair cascade file accessible to everyone? Hair cascade file is downloadable. You have downloaded it. Okay, that's okay. So this will only work on offline ID. It will not work on collab, right? So just try to do it on the offline ID. Okay, so you can finish this thing. You give it a little time, and tomorrow I'll tell you about something about the object detections of different kinds of object detections through SSD model. The SSD model that is very popular. So we'll see that part and some more stuff. So we'll see. We'll discuss that can be done quickly. So that is it from my side for today. Because if I start anything now, that will not finish. So the better you can just finish this part. Okay, whatever that I have shared today, because it is not offline, it is not online, it is not done on the collab. So it may take a little time to understand the things. So just give it a little time to understand. Okay, and thereafter, in the next session, we'll go for the more advanced part of it, right? Just have a practice with the CNN and these all things before the last session, so that we can have a discussion with doubts and all, right? So if you're having anything to ask, please let me know. Else we can sign up for today's session. Do you have anything to ask right now? Offline file I have shared it through WeTransfer. I hope you can download it from the link. Just a minute. Let me share it again. DICOM. Okay, fine. I'll tell you about the DICOM image as well, right? I'll tell you the DICOM image tomorrow. Okay, just remind me once. Okay, I have to just get the data. I have to just find out the data from here from the Kaggle. Just a minute, let me check. I guess some project may be there on Kaggle related to DICOM image that I did earlier. Okay, just give me 1 minute. I'll just do it. You can just work on that part. There must be some project I did earlier. I'll just figure it out. I'll share the link and you can just work on that. It's a very simple process. Just a minute. It's a notebook, brain tumor, brain MRI, cats and dogs, sign language association must be there. Because I remember I guess some time back, like around 2, 3 weeks back, someone asked me the same thing that ICOM or something. Yeah. So I just told him, oh yeah, it's that how to use DICOM image, right? So it is how here is the image directory. You can access it. You can click over it. Okay. When you click over it, you'll get what? You'll get the DICOM images, right? So first of all, accessing it, there's a PyDICOM library through which we are doing it. Okay. Then DICOM.read file through which you can read it, right? And thereafter print im1.pixel array. You'll get the pixel array. That means the pixel array is what? It's a pixels of the image, right? And this is a save. Okay, and then you can get the image as well. Okay, like this. Okay, then it's a image 2. It's just it is the second image. Okay, so same thing we did over here for the image 2 as well. Dicom.read file. Okay, you have to extract the feature of all the image. You can put the things into the loop, right? And then you are doing it toward just accessing the image and all, and thereafter setting the aspect ratio, okay, coronal aspect ratio, another aspect ratio, right, of the images, and then doing it, right? So I'm sharing this file with you. You can just execute this thing one by one, and it's a very simple process. You can access it and work over it, okay? And thereafter creating neural network model also there. So we created the neural network model also. Accuracy was also good. Let me check what is the last accuracy that we got. I got the accuracy of around, I don't know what, it's a 40%. Okay, 40% accuracy, 50% or 40%. There may be not good data, but anyway, that accuracy can be enhanced by using a more in-rich data set. Data set is not too much rich, I guess. Anyway, so you can work on it, right? It's a simple process. I'll share this file with you. It is on my Kaggle account only. If you are having access of my Kaggle account, you can get it, or you can use this link, kaggle.com/Bipul/deep learning DICOM, whatever it's there. Okay, is it fine? You can go through it. I hope this code will help you, right? Okay, what does minimum neighbors 5 means? It's like if you are using over here, when it is going to detect the faces, right? It will do what? It will, where is it? Yeah, it will pick at a single time. It will just analyze 5 different part of the images. Okay, with a scale factor of 1.1, and 1.1 is scale factor from right, from left, from top, from bottom. Okay, so with a scale factor of 1.1, it's like it will analyze 5 different images and compare that image with what, with the hair cascade file that is given over here to detect the face. So if you want to work this thing faster, you can increase the number of neighbors. If the number of neighbors will be lesser, in that case it will work little slow, right? Yeah, so you can, I guess you can go through the file that I have shared for the DICOM image as well, right? Yeah, please go through it and let me know if you have any doubt from there to us. Okay? Because someone was working on image, sorry, health, this health sector project, and they asked me about this DICOM image. Then only I worked over that. Generally, we don't use the DICOM data because our projects are not like that. But yeah, if you want to work, you can work on that. So, is there anything to ask? Please tell me. Okay, so shall I sign up for today?
Okay, sir. No issue. Thank you very much.
Okay, thank you. Thanks a lot, sir. Take care, everyone.
Sir, tomorrow you have session 2,
Session two will start from 12.
12:45 to 2:45.
Okay, that's fine.
Morning session is for Dr. Donika
Okay,
on
so that's
emotional intelligence. So you please join tomorrow in
right.
session 2.
Right.
Yeah. Only one session is left.
Yeah, right.
Okay, sir. Thank you very much.
Thank you. Take care. Have a good day.
All participants are kindly requested. Please follow tomorrow's schedule. Morning session is based on emotional intelligence by B.K. Donika. Second session by Mr. Vipul Shahi. And third session will be for your test MCQ type for 50 marks. And feedback you have to submit on AICTE portal by doing your login credential. All two link tomorrow's 2 session links I have shared on your email. For third, that is for test, I'll send you email of Google form. Thank you very much. See you.